Hello students and welcome to the review session on lines in a plane. And we're going to start here with the definition of slope. Okay? So slope is basically the ratio of vertical change to horizontal change. And when we talk about lines, we can write the equation of a line using several different ways, but probably the most common way is what's called slope-intercept form. Okay? And you're probably familiar with this as y equals mx plus b, where the m is the slope and the b is the y-intercept. In other words, it is the point where the graph crosses the y-axis. Okay? So if I had a graph like this point right here would be the y-intercept because that's where the graph actually crosses over the y-axis. Okay? And so one of the questions that we face is, do all lines have the y-intercept, or is it just some lines or most lines? Well, we can look at some examples here. If you have this graph here and you have a slanted line, basically any sort of line, this clearly has a y-intercept. So basically any sort of line that's a little slanted, you can see that it has a y-intercept. Even some horizontal lines also have a y-intercept. And just about any line that is non-vertical, so has a y-intercept. So if you have a line like this line right here, this vertical line, I'm going to label this the y-axis, this is the x-axis, and this is the graph. This line right here clearly has no y-intercept, and in this case, it also has no slope because the slope is going to be infinite. Okay, and we'll see some examples of that shortly, but the main idea here is that vertical lines have no y-intercept and undefined slope. Okay. And so let's look at a few examples on this. So another way that we can define slope in sort of precise mathematical terms, and we're going to use the letter m, the variable m, to represent slope, is equal to y1 or y2, I'm sorry, minus y1 over x2 minus x1. And this is the traditional definition of slope, change in y over change in x. Okay, so I have an example here. I have 2 points, x4 and 611. So one of the points we know the coordinates for, the other points we do not know the coordinate for, and we know that the slope is equal to 2, and we're asked to solve for x. So in order to set this up, we simply set up our slope equation. We know that the slope is 2, which is equal to y2, 11, minus y1, 4, divided by x2, which is 6, minus x1, which in this case is the variable x, and our goal is to solve for x. And so we do this, multiply both sides by the denominator, so you get 2 times 6 minus x equals 11 minus 4, which is just 7. Distribute, you get 12 minus 2x equals 7. Subtract 12 from both sides, you get negative 2x equals negative 5. Then divide both sides by negative 2, and x is equal to 5 halves. Okay? So if we substitute 5 halves in here, we should end up with a slope of 2 with this other point. Okay? So this is a problem of solving and using slope to solve a problem. And so let's move on to some more complicated examples with parallel lines, perpendicular lines, and finding the equation of a line in general. Okay, so here I have an example that's asking me to find the equation of a line through these 2 points, 4, negative 1, and negative 4, 5. And one thing to remember is that you can always find the equation of a line as long as you have a point and a slope. Okay? Well, here we have 2 points. So we can definitely use those 2 points to find the slope. So the first thing we want to do is find the slope, which is y2 minus y1 over x2 minus x1. And we come out with 6 over negative 8. Or to simplify that is negative 3/4. Then we can substitute that into our slope slope-intercept form. So I'll make a note on the side here. So we have y equals the slope, which is 3/4 x plus the y-intercept. And now if we can just find the y-intercept, we will have our answer. And to do that, we can just use one of these points, and it actually doesn't matter at all which one of those points we use. So for the sake of solving the problem quickly, and it really doesn't matter, I'll just pick this first point here, and I was going to substitute -1 here in for y. -3/4 is still my slope, +4 in for x, and I'm going to solve for the variable b. So this gives me -1 is equal to -3 plus b, which means that when I add 3 to both sides, I get 2 is equal to b. So my final answer is y equals -3/4 x plus 2. And there you have it. That is a solution to the problem using slope-intercept form. So we've seen some examples with slope-intercept form, and now let's look at general form. And this again is a different way of writing an equation. We can definitely convert any slope-intercept form into general form and vice versa, but this is another way to write it, where you have ax plus by plus c equals 0, as long as a and b are not both 0. So one of them may be 0, but they can't both be 0. Okay? So let's look at our example here. I believe this is example 3, where let's say convert -3 or y equals -3/4 x plus 2 to general form. Okay. And to do this, it's not terribly difficult. We basically just need to rearrange it so it looks like this format. So I'm going to move positive or -3/4 x here to the left side, so add 3/4 x to the both sides, and you get 3/4 x plus y equals 2, and then move 2 to the left side as well, 3/4 x plus y minus 2 equals 0. And this is general form. And again, this is a different way of writing the same equation, but in pre-calculus and especially in calculus, there's a lot of problems where when you're graphing them, it's actually easier to graph it using general form. It's actually easier to identify certain characteristics of the graph. So for lines, though, slope-intercept form is probably the most common, but you will see general form on some assignments. So we can look at some cases with parallel lines, and one of the things that we know about them is that they always have the same slope. So let's say I had an xy coordinate, and I had two lines. We'll call this here, this blue line here, L1, and we'll say that the slope here is M1, okay? And we have another line, a red line, we'll call this one L2, and that slope is M2. And this is a proof in geometry that when you have two parallel lines, their slope must be equal. So we know for sure from a proof in geometry that M1 and M2 must be equal if L1 and L2 are parallel. Okay, so if L1 and L2 are parallel, M1 and M2 have to be equal. And since this is a review section, I'm not going to go too deep. I'm not going to go into the proof at all, but you should see one of the other videos or talk to your teacher if you want to see a deeper explanation of this. Okay, so here I have a problem that deals with parallel lines, and it says write the equation of a line that's parallel to 2x plus 5y equals 12, and it passes through 4, 7. So this line that we're given here, we want another line that's parallel to that and that goes through this point. So let's just look at this line and let's convert it to slope-intercept form. Okay, so convert this to slope-intercept form. I get 5y equals -2x plus 12. And then I'm going to divide everything by 5. So y equals -2/5 x plus 12 over 5. Okay, so this is slope-intercept form. So I need to find a line that's parallel to this line and goes through this point. Okay. So just to illustrate graphically, there's this line right here that has this slope. It's negative. We'll say this is y equals negative 2/5 x plus 12/5, and I need to find some other line that has the exact same slope, but rather passes through 4/7. So 4/7, we'll say it's somewhere here. I need another line that's exactly parallel to it with the same slope. And what's the equation of this red line right there? Okay. Well, we know that parallel lines have same slopes. Okay. So whatever the equation that I have for this red line, I know it's going to be y equals negative 2/5 x plus something, right? Because it's got to be parallel to this black line here. And then since it passes through 4/7, I can use 4/7 to help me find the equation of the line. So I can substitute in 7 for y, 4 for x, and I almost wrote 12/5 there, but it should be plus b because that's what I'm looking for. And then just solve this problem. So 7 equals negative 8/5 plus b. Add 8/5 to both sides, and that's 43/5 is equal to b. So that means the equation for that red line is y equals negative 2/5 x plus 43/5. Okay, so that was example 4 with a example where we look at the relationship between two parallel lines. Okay? So let's continue here and let's look at some perpendicular lines. Okay, so perpendicular lines have slopes that are opposite reciprocals of each other. So to illustrate, if I have an xy coordinate plane here, and I have a blue line here, and we'll call this L1, and it has slope of M1. And then I have another line that's perpendicular to that. My drawing's not really great here. And this is L2, and that has a slope of M2. One thing that we can say is that if L1 and L2 are perpendicular to each other, then M1 is equal to the opposite, so there's a negative sign, and the reciprocal of M2. And we can also say that M2 is equal to the opposite reciprocal of M1. So both of these equations are equivalent. Now, this is a biconditional, so if the slopes are opposite reciprocals, then the lines are also perpendicular. But generally in pre-calculus, we usually use the forward condition more often. And there's a great proof for this in geometry, but we're not going to go too much into detail about that right now. Please see your teacher or watch one of the geometry videos to see that proof. Okay, but the main idea is that if two lines are perpendicular, then the slopes are opposite reciprocals of each other. And so let's take a look at an example. Take a look at an example at how to use this idea. So I have an example here that asks for the equation of a perpendicular line. It says write the equation of a line perpendicular to this other line and passes through this point. So again, sort of like our example with the parallel lines, we're going to take this equation and just convert it to slope-intercept form. Okay. So we get 7y equals negative 3x plus 17. And then divide everything by 7, so you get negative 3/7 x plus 17/7. Okay, so that's the equation. And from this, we know that the slope of, this is right here, that's the slope, and this, we can call this M1. Okay? But the line that we're looking for is really M2. So to illustrate, just a quick sketch here, if we have a line here that goes this way, and has a slope m1 equals to negative 3/7, the line that we are looking for is actually perpendicular to that, and it's got to have a slope of m2, which is the opposite reciprocal of this, so that has to be 7/3. So if you remember, when you have a perpendicular line, m1 is equal to the negative reciprocal of m2, or we can also say that m2 is equal to the opposite reciprocal of m1. Both are perfectly true. Okay, so we do know that m2 that we're looking for has to have a slope of 7/3, positive 7/3. So from that, we can set up our equation. Y equals 7/3 x plus b, and then use this point here to find the value of our y-intercept. So substitute in 5 for y, negative 9 for x, solve for b, and you get 5 equals negative 63/3, or excuse me, that's just negative 21. Okay. And that means 26 equals b. So our answer is y equals 7/3 x plus 26. And this is the equation of a line that is perpendicular to this line and goes through that point. And so there you have it, an example on finding the equation of a line given something that's perpendicular to that line.